What is sequence? Now, sequence is a finite number of statements which are executed one after another, and these finite number of statements constitute this sequence block. Let us call this sequence block as S. Now, as each of these statements within this sequence block is a basic step, so and the number of basic steps in this sequence block is finite, let's see. So we can say that this sequence block requiring c unit of time. So we can say that the sequence block requiring c unit or constant unit of time, or we can also say this will take constant time or 1 unit of time, because it doesn't matter what is the value of this unit, we can consider this c as a larger value of our unit. So as a conclusion, we can say the sequence block takes 1 unit of time, more accurately c unit of time, where c is the finite number of statements within the sequence block. Next, selection. Selection means simply if then else. So there is a part like if some condition, if this condition is true, then this true block, this will be executed, true block statement. It is basically a finite block. Else, false block, that is also a finite block, and end if. So basically either this true block or false block will be executed, and then control will come to this common statement. Now why we are calling this as common statement? This is because irrespective of this true block or false block, this statement will be definitely executed. So this is common statement. Now how to analyze this part of the algorithms efficiently? So we can say that running time for this part is running time to check the condition if this is C plus maximum of true block and false block, because we do not know that which of these two blocks will be executed. So we are considering the maximum time of these two to include the worst case situation. So this is the running time for this part. Okay. Next is iteration. Iteration means repetitions or function call. Now there can be two situations where the number of iterations, okay, is counted separately and we can sum up all these total counts, or we can just understand that what is the loop body, what is the time required for the loop body, and that time multiplied by the number of iterations. Now let us take an example. Suppose we have a loop like this for I is equal to 1, I less than equal to n, I plus plus, and this S means sequence block, and n for. So as for our previous discussion, this sequence block requiring 1 unit time or c unit of time, and every iterations of this loop requires 1 unit of times. This will require 1 unit of time. And how many times this is iterated? N times. So for every iterations this will be iterated. So this will also take n unit of time, though this unit and this unit are different, but doesn't matter, or more accurately we can say this is n into c. This c can be considered as unit because that is the logic for asymptotic analysis, n into c. So what we are doing, we are calculating the running time for the loop body multiplied by the number of times it iterates. So this is one case. There can be another situations where the iterations of the inner loop is depending on the iterations of the outer loop. Now let us take one examples of that kind. For I is equal to 1, I less than equal to n, I plus plus, and for j is equal to 1, j less equal to I, j plus plus, and s. S means sequence block, n for n for. So we are interested to calculate what is the analysis for this part of the algorithms. Now understand the difference here. Here the inner loop is dependent on the value of the outer loop, because whatever is the value of I, that controls the number of iterations of the inner loop. So in this case we cannot simply multiply the number of iterations of the outer loop multiplied by the inner loop. That we cannot do. In this case we require to unroll the inner loop based on the outer loop. Now let us apply the same technique here. Every iteration of this is a basic steps requiring 1 unit of time. This will also take, every iterations will also take 1 unit of time, and this sequence block will also take 1 unit of time, because we are considering this unit as larger unit. Now this will iterate how many times? N times, because from 1 to n this will requiring n unit of times. Now let us understand how many times this will iterate. So when I is equal to 1, this loop iterates from j is equal to 1 to 1. So for I is equal to 1, okay, j is allowed values of j is 1. Now when I is equal to 2, the inner loop iterates 2 times. So what is the total value? So the value for this iterations count, that can be calculated as 1 for I is equal to 1, 2 for I is equal to 2, 3 when I is equal to 3. So when I is equal to n, that is n times. So this is the total number of iterations of this for loop. So that is nothing but n into n plus 1 by 2. So this much unit of time is required by this for loop, and for every iteration, let this is k, let this is k times. Now k is this value. Now this will also iterates k times, because same as this, so this is also k. So if I calculate the total time consumed by this for loop, nested for loops, that can be said as n for this plus this is k, and this is also k, that is 2k. So this is nothing but n plus n into n plus 1, because these two cancel out. So this is nothing but n square plus 2n. So this is the way we can consider the iterations. Okay. Now next is function call. Fourth construct is function call. Now what is function call? From caller another procedure will be called. So control will be transferred from the caller to the call function, and after executing the call function, control will be again transferred to the caller. Suppose this is caller, these are the statements of the caller, and after executing all these statements, there is a function call, like fn is the function, this function is called, and after that there are other basic steps. So from here control is transferred to function. This is start of the function, this is end of the function, and these are the statement within the function. So whenever control is transferred to this place after executing this part, again at the end the control is transferred to the caller. So how to analyze this kind of situation? In this case we will consider this function as a separate algorithm. We will apply the same techniques which we have discussed earlier, and those analysis result will be substituted in the calling statement. Suppose the analysis result is 2n plus 1. For example, let this analysis. So what we will do, we will substitute this analysis result here. So, this is not a basic steps, rather this will take 2n plus 1 unit of time, and if these are all basic steps, these are all requiring 1 unit of time. So, again this is a sequence block, but this in this case there is a control jump and this requiring 2n plus 1 time. So, to evaluate this part, the running time will be the maximum of the running time of the statement within the block. So, this is 1 unit, this is 1 unit, but this is not 1 unit, this is 2n plus 1 unit. So, as a whole the total time is depending on 2n plus 1. So, in this way we can calculate.